Okay, so here we are with the trigonometry questions. All right, so without further ado, let's get into it. So, first one, A, simplify tan theta sine theta plus cos theta. All right, now here's what you need to do. You need to notice, okay? You need to notice that tan theta sine theta, okay, plus cosine theta is equal to sine squared theta over cosine theta plus cosine theta. I'm just going to say cos from now on. All right. Cool. So where do we go from here? Well, let's think about it, right? What is cos theta, really? What can we say this is? We can say this is cos squared theta over cos theta, right? Because you cancel that out. So, from here we can say, okay, fine, we've got sine squared theta over cos theta, alright? And then what we're going to do is we're going to add cos squared theta over cos theta. And what's that going to equal? Well, remember, what's our common denominator? It's cos theta. So what we're going to have is sine squared theta plus cos squared theta over cos theta. You know what this looks like to me, guys? This looks like 1 over cos theta, which gives me sec theta. Right? And that's not just maths. That's art. That's beautiful. Okay. Now, B. Find the general solution to tan theta sine theta plus cos theta equals 2. All right, what are we going to do here? Quaking in my boots. What are we going to do? Well, I'll tell you what to do. What you want to do is you want to say, okay, we've got sec theta is equal to 2. All right. And what's sec theta? Well, sec theta is 1 over cos theta. All right. So 1 over cos theta is going to equal 2. All right. So from here on out, this is going to be cos theta is equal to a half. All right. Now, if I get my trusty calculatrice over here, and I say, all right, in radians now, arc cos for half, what's it going to give me? That's going to give me pi over 3. Okay. So theta is going to equal theta is going to equal pi over 3. Let's n dot 2 pi. Okay, because this is our general solution here. Didn't ask for any specifics, it just asked for the general solution. Okay, and that's question 1, right? So not too shabby, not too bad. Okay, so now let's go through question 2. Okay, so question 2 is telling us find the general solution to sine theta plus cos theta is equal to the square root of 6 over 2. Okay, so how are we going to do that? Let's go 2a. All right. Cool. Now, what I'm going to do over here is I recognize that if we multiply by square root of 2 over 2, okay, we can get this equation in the form of sine x plus a equals b. Okay, and I say that because once we times by square root of 2 over 2, we'll be able to put it in the form of the special angles, the special triangles even. And that's going to allow us to solve this much better. Okay, so let's give it a go. So, times by square root of 2 over 2. Okay, so what we got then is square root 2 over 2, sine theta, okay, plus square root of 2 over 2 cos theta, okay, and that's going to give me root 3 over 2. Great. Now, remember, this is where things get interesting, right? So if you look at the triangle on the screen now, you'll be able to see the special angles, okay? So what we can say is, instead of square root 2 over 2, we can say sine pi over 4 and cos pi over 4. So I can say cos pi over 4 sine theta plus plus sine pi over 4 cos theta. Okay, what's that going to equal? That's also going to equal square root 3 over 2. Okay, and now I can simplify this further. Okay, because using this form, okay, I can put it in this form because we're using compound angle formula. Okay, we use compound angle formula. This becomes much easier, and this simplifies down to sine theta plus pi over 4 is equal to square root 3 over 2. Okay, so from here we just take the arc sine, so that's going to be theta plus pi over 4 is equal to, okay, now if I grab my calculator here, that's going to give me pi over 3 plus n times 2 pi, okay, because remember, what I'm dealing with here is the general solution, okay, and so if I get this, we can go, okay, pi over 3 minus pi over 4 okay, that's going to give me 1 over 12 pi plus, sorry, my pen is terrible right now, n times 2 pi, okay? Cool. But that's not it. It's not it. Remember what we do with trigonometric equations. Can you remember? I'll tell you. This is not our only solution, because remember, we can draw ourselves a little cast diagram. Okay. So here, what we can do is we can put pi over 3, okay, because this is our original form. We're going to deal with this one now. So we put pi over 3 there. Now remember, the quadrant represents where the function is positive. So this is where all the functions are positive. This is where tan is positive, this is where cos is positive, and this is where sine is positive. So where are we going to put sine? No, sorry, where are we going to put the second angle? What's going to be in this one, right? Because the sine angle is positive. Okay. So this is going to be our second angle over here. Theta 2. Okay. This is theta 2. Now theta 2 is equal to 180, so in this instance, pi minus theta, okay? So theta 2 is going to equal 2 over 3 pi. So we're going to say theta 2 plus pi over 4 is equal to 2 pi over 3 plus n dot 2 pi. Okay, great. Okay, so theta 2 is then going to equal 2 pi over 3 minus pi over 4. Okay, so theta 2 then is going to equal to 5 pi over 12 plus n dot 2 pi. So as you can see, we have now got two solutions for this equation. Okay, great. Now what about B? What are we going to do for B? Okay, so to be or not to be, right? Now think about it. Sine theta plus cos theta, what does that equal? Okay, well, that is going to equal sine theta plus pi pi over 4. Okay, why? Why is it equal that, Nick? Well, let me tell you. It equals that because we showed it does. That's why. What can I say? I'm a genius like that. All right. Sine theta plus cos theta equals to this. Okay, and we show that. So great. Now we just got 2 on the right hand side. So we just put 2 on the right hand side. And what happens when we put 2 on the right hand side is they're trying to pull a little sneaky on us, but we're not going to let them. Okay, because let's say this. Okay, let x equal theta plus pi over 4. Okay, so then sine x then is equal to 2. Okay, sine x equals 2. But think about it. Look at the graph that's on the screen now. Okay, give it a pause if you need to. What do you notice about the properties of sine? Here are the properties of sine. Okay, sine x has to be a smaller one. Okay, we can't go above 1. We just can't. Okay, and what do you know? 2 is bigger than 1. Okay, so this is complete nonsense. It makes no sense. This is a trick question, guys. It does not make sense. It is physically impossible. It just won't work. Okay, so we can therefore say no real solutions present. Okay, I might actually put therefore. Alright, so no real solutions can be present here. Alright, number 3. Alright, what is number 3 telling us to do? Number 3 wants us to verify that 1 plus sine 2x is equal to sine x plus cos x squared. Okay, so the question is, how are we going to do this? Well, okay, let's take a look. Here's what we're going to do. 3a. Okay, we're going to start on the right hand side. What I'm going to say is I'm going to multiply it out. Okay, because I don't like the way it's looking at me. I need to multiply it out. So I'm going to say fine. Sine squared x plus 2 sine x cos x plus cos squared x. Alright? Easy peasy. Lemon squeezy, right? Because now what we got is sine squared x plus cos squared x. Okay, so rearrange. We got 2 sine x cos x plus sine squared x plus cos squared x. All right, now that is beautiful. All right, guys, again, like I said before, it's art. That's what it is, it's art. So what we got is 2 sine x cos x plus 1. Okay, and we can go with it even further than that, actually. This guy over here can be turned into, well, what can it be turned into? It can be turned into sine 2x, okay? So we can say sine 2x plus 1. 1 plus sine 2x. Cool, and that's the answer. Alright, now for number B, we just have to use the information for number A to solve this question, because it's actually simpler than we think. So if we take a look here, firstly, 1 plus 2x, we know, is the same as saying sine x plus cos x squared, right? That's pretty simple. I mean, that was what A told us. And so from here, it's naturally just going to equal sine squared x plus 2 sine x cos x plus cos squared x. Okay, now at the same time, we can say that, okay, this 1 plus 2x is equal to this. Okay, it's equal to sine x plus cos squared x. So we can therefore say that from A we can say that sine x plus cos x squared is going to equal sine x plus sec x squared, okay? Alright, now from here, what do we do? Well, from here, we just need to say, well, okay, what is this equation actually telling us? Well, it's telling us that the square of sine x plus cos x is the same as the square of sine x plus sec x, which therefore tells me that the absolute value of sine x plus cos x, okay, the absolute value here is going to equal the absolute value of sine x plus sec x, okay? And what does that imply to us? Well, what that implies is that, okay, well, all of these are positive in the interval 0 to pi over 2. That much is, we know that. Okay, so they're all going to be positive. And so from that, what I can say is that, fine, I can say that sine x plus cos x is equal to sine x plus sec x. And what does this tell me now? Well, we can just solve from here. So we can cancel out the signs. I can just say find cos x is equal to sec x. So I can therefore say that cos squared x, okay, is going to equal 1. And from here, it's pretty simple because, well, if we look between 0, x, with x being between 0 and pi over 2, we know that x equals 0 is the only solution, okay? And so, knowing that, we know that 0 is going to be the only solution here. Okay, number 5. Find sine of 75 degrees using the compound angle formula for 30 degrees and 45 degrees. Okay, so if you recall the compound angle formula, I've linked the formula sheet below. Sine 75 degrees, okay? So sine 75 degrees okay, what's that going to equal? That's going to equal sine 30 degrees plus 45 degrees. Okay. 30 degrees plus 45 degrees. Great. Using our compound angle formula, well, that's going to give me sine 30 degrees cos 45 degrees plus sine 45 degrees cos 30 degrees. Okay, so what can I say from here? Well, I can then say that sine 75, okay, sine 75 degrees is going to equal half square root 2 over 2 plus square root 2 over 2 times square root of 3 over 2. Okay, so we've got half times square root of 2 over 2 plus square root of 2 over 2 times square root of 3 over 2. Okay, now if you look closely, what does it turn into? Well, it can turn into root 6 plus root 2 over 4. Okay, and that then will be our answer. Okay, so pretty basic question, just a bit of a explanatory question, but relevant all the same because it demonstrates the value of the compound angle formula. Okay, now number 6. Okay, write 7 sine theta plus 11 cos theta in the form r sine theta plus a. Okay, and get a correct to 3 significant figures. Okay, so what are we going to do here? Well, okay, let's think about it. So, sine theta plus alpha Okay, this over here. What is sine theta plus alpha equal to? Sine theta plus alpha is equal to sine theta cos alpha plus cos theta sine alpha. Okay? And so, what can we say? We can say, therefore, r sine theta plus alpha. Okay, so we times by r now. That's going to give me r sine theta cos alpha plus r cos theta sine alpha. Okay. Cool. So then, yeah, that's right. Cool. How do we get r? Right, how do we get r? Right, so r, if you recall the formula, so you're going to get r. Okay. Now r is going to equal 7 squared plus 11 squared. Okay. And that's going to give me a value of root 170. Okay. And so we can say that cos alpha is equal to 7 over 170. And sine alpha, is going to equal 11 over 170. Now, okay, cool. Where does this come from? Now, this effectively comes from our formulas, right? So, think about it. This is r sine theta plus alpha, okay? And this is what we get. Now, if we got 7 sine theta and 11 cos theta, then if we got sine theta here, then r cos theta, okay, is going to equal 7. That makes sense, right? R cos theta is going to equal 7. Cos alpha, and then r sine alpha, okay, is going to equal 11 because it's the coefficient of cos theta. Same thing here. R cos alpha is the coefficient of sine theta, and here r sine alpha is the coefficient of cos theta. Okay, so you just work with that. All right. So you get these values. All right, and what do we do from here? Well, okay, we are now. Okay, so we got our values here. Brilliant. So now what I'm going to say is I'm going to say 7 sine theta plus 11 cos theta is going to equal square root of 170. Seven over square root 170 sine theta. Okay, then we're going to also add in that plus 11 over 170 cos theta. Okay. Now why have we done that? Well, it's just recalling. Remember, we plugged these into the formula up here, and now we just simplified it. Okay. So from here, it's a simple case of just going fine. What do we do now? Well, glad you asked that, because what we're going to do is we are going to put this in a special form. Alright, so we can then say this is going to equal square root 170 so we can officially say that the square root of 170, okay, cos alpha sine theta plus sine alpha cos theta, okay, is going to equal 170. I don't know why I did this that big. Equals to square root 170 sine alpha plus theta. Okay. So what can we say now? What we can now say is that alpha, okay, alpha then is going to equal cos, inverse cos of 7 over square root 170. Okay, and that's going to give me a value of 57.5 degrees. Okay, and that is number 6.